T9. A 150 centimeter tall person stands on the bank of a narrow river and observes a flagpole on the opposite bank. If the angle of elevation to the top of the flagpole is 0.25 and the angle of depression to the bottom of the flagpole is 0.09, determine the flagpole's height in meters to 2 decimal places. Correct? So let's first draw a sketch to represent the situation, right? Think like this, that this is the narrow river, okay, and we have a flagpole here at the end of the river. Let's say that's the flagpole, correct? That is our flagpole, right, at the end of the river, and a person standing on this side with the height of 150, right? So we'll say this is the height of the person, which is 150 centimeters, right? Now from here we'll have angle of elevation, that is what angle eyesight makes with the top and the base, right? So that is the angle of elevation, and we will have angle of depression, which will be from here to the foot, right? So we'll connect these two like this, correct? So that becomes the angle of depression, correct? So that is how we'll draw our sketch. Now let us assume that the width is W. This is the width of the river, right? That is the width, right? This is 150, but in centimeters, correct? 150 centimeters. The angle of elevation given to us is 0.25 and the depression is 0.09. When no units are written, it is radians, okay? Now, so let's say total height is h, and let's say this height is h1 from inside, right? From here to here, correct? Let's say this is h1. So we'll add 150 centimeters to get total height of the flag. Now what we can do is that we can solve this bottom part. Let's say this is the person at A and this is our B and this point is C and this is D, right? Then let's consider the triangle ABD, right? In triangle ABD, which is triangle ABD, we have tan of 0.09 equals to 150 over W, right? 150 over W, where W is the width of this river. So W could be written as 150 divided by tan of 0.09, correct? So we can use our calculator and calculate this answer. So it is 150 divided by tan of 0.09, which gives us 1662. So this is equals to 1662, and this is all in centimeters, right? We want in meters to 2 decimal places, so we'll change the units later. Let's do it in centimeters first, correct? So we get width of 1662. Now we have solved the lower half of our triangle. Let's do with the other half of the triangle, which is ABC. So let's consider triangle ABC. Now here tan of 0.25 is equals to h1 over width W, right? Now width is 1662, so we'll use that now and find height, right? So we say h1 is equals to W times tan of 0.25, right? W is 1662. So let's plug in 1662 and to 1662 times tan of 0.25, and we get 424.37. Let's say this is 424, right? Forget about 0.37. We are already working in centimeters, right? So we have this additional height of 424. We place W as 1662 in this calculation, right? So yes, right? So remember that part. Now total height h will be equals to 424 h1 plus 150, correct? Plus 150. And that is equals to 574 centimeters, right? 574 centimeters, or this could be written as 5.74 meters. That is to 2 decimal places, correct? So that is how we are going to solve this problem. I hope you understand. Thank you.